Hi everyone. Today I'm going to show you how to do a basic Mohr circle problem. For this exercise, you're going to need a drafting compass, your protractor, and a calculator. The problem that we're going to do is here. So the problem is, given principal stresses of sigma 1 equals 640 megapascals and sigma 3 equals 160 megapascals, plot the corresponding Mohr circle. And as part of this, we will determine what is the mean stress and what is the differential stress. So here's my graphing paper that I will use, and I'm going to leave the problem shown up there. Okay. So we're going to start by this problem by plotting sigma 1 and sigma 3. So here's our Mohr circle graph, and as a reminder, our x-axis here is normal stress and our y-axis is shear stress. Because the principal stresses are defined as the maximum and minimum normal stress, and they act on the principal planes where shear stress is 0, we know that we will plot these points on the x-axis. So we'll start with sigma 1 equals 640, which we'll plot right here, and sigma 3 equals 160, which we'll plot right here. I will label those sigma 1 and sigma 3. Now we need to draw our corresponding Mohr circle, and before I do that, I like to determine where I need to put the needle of my drafting compass, which will be the center of the circle. And the center of the circle is also the mean stress. So we'll go ahead and calculate our mean stress here, and as a reminder, mean stress equals sigma 1 plus sigma 3 over 2. So here we'll calculate that as 640 plus 160 over 2, which equals 400 megapascals. So the center of our circle is going to sit right here. Sigma mean. Now I'm going to grab my drafting compass and go ahead and get this set up. Put my needle right on the center of the circle there. Adjust my compass so it reaches out to the edge. And draw it in. So there we go. I have now drawn the corresponding Mohr circle to those principal stresses. I have to determine my mean stress here already, which equals 400 megapascals. And the differential stress is next. And recall, differential stress, this is just the mean of those two. It's the diameter of this circle. So that's just sigma 1 minus sigma 3, which equals 640 minus 160 equals 480 megapascals. Reminder, that is the diameter of the circle, so the difference between sigma 1 and sigma 3. I'll write that up here. Equals 480 megapascals. So the next part of this problem is to determine the normal and shear stress on a plane with a specific orientation. The problem is to plot a plane, plane A, that is oriented 50 degrees clockwise from sigma 1, and then determine what is the normal and shear stress on that plane. So in order to plot this, to solve this problem and plot it on a Mohr circle, the value that we really need to determine is theta. All right, remember theta is defined as the angle between sigma 1 and the normal vector to our plane of interest. So we're given 50 degrees clockwise from sigma 1 as the orientation of the plane, but that is not theta, right? Because theta is the angle between sigma 1 and normal to our plane of interest. So I'm going to go ahead and go to my sigma 1, sigma 3 plot here, and I'm going to start by plotting this plane, which is 50 degrees clockwise from sigma 1. I'm going to grab my protractor, set it up there at the origin. 50 degrees clockwise from sigma 1 is going to sit right here, and I'm going to draw that in. I'm going to label that plane of interest A, okay? And this is 50 degrees, and that is clockwise from sigma 1, so we're all set. Now to determine theta, I first need to get a normal vector to this plane. So I'm going to draw a line that is 90 degrees from our plane of interest. And this is going to be normal to plane of interest A. All right, so that's a right angle right there. And this angle is 40 degrees, and that is counterclockwise. And this is our theta angle. So theta for A equals 40 degrees counterclockwise. Now, in order to move this into Mohr space, we have to double the angle. Remember, all angles are doubled in Mohr space. What we actually need here is 2 theta, which is 80 degrees counterclockwise. So I can now move to Mohr space, and I'm going to measure this 2 theta angle from sigma 1. That's how it's defined. It's defined as being measured from sigma 1. And I'm going to measure 80 degrees. So I'm going to draw a line, a radial line connecting to the circumference of this circle. And here, this point here, along the circumference, represents my plane in this space. So to determine the normal and shear stress on this plane, I simply read it off the plot. So my normal stress, come down to the x-axis, is about, I'll write it over here, is about 440 MPa, and the shear stress, which I'll read from right here, is approximately 240 megapascals. And recall this is our 2 theta value. So to answer this question, what is the normal and shear stress on this plane? Our normal stress is 440 megapascals, and our shear stress is 240 megapascals. So that's how you solve a really basic Mohr circle problem. I have another one here that I will do, and I will post that in a separate video.